Hey there, welcome back to CMTEQ channel in part 2 of our tutorial on arc flash analysis. If you'd like to know how we got here, I recommend that you watch part 1 of this tutorial. So now that we've completed the simulation in DIgSILENT using the IEEE 1584 standard that basically define the definition or calculations metrics for the arc flash analysis. It is now time for us to actually try to understand what these results mean for us in terms of the system safety and the PPE category. As we can see here, this is category 4, right? So we've got a bus bar here, 132 kilovolt, and the results show that this bus bar is rated at category -1. And over here, our lowest rated bus bar at 33 kilovolt has category 4. This tutorial is all about interpreting the result of our arc flash analysis. So let's dive in. Great. Now for the 132 kilovolt bus bar, we've got an arc current of about 43.7 kiloamps, which is basically the short circuit current on this bus bar here. And this is at a calculated incident energy of 1493.4 joule per centimeter square. So it's very high, okay? And this is the incident energy at the arc source, basically where it is occurring. And the same result also gave us an arc flash boundary of about 14.7 meters. Now, notice here that the PPE category is -1, okay? So which here on our result box says it's not applicable, okay? Now, why is this the case? Now, in terms of DIgSILENT PowerFactory, this basically means that the incident energy at the defined working distance is actually below 1.2 calories per centimeter square, which is a standard for category 1. So if we are below that, then we're going to be below category 1. That's why it says here not applicable. But now, why is this the case, right? Because the arc incident here is extremely high. It's 149300, which is about 360 calories per centimeter square. Very, very high heat energy. But obviously, the information that we entered on this bus bar, they were randomly selected, right? Just arbitrary numbers. This is not based on real power system network data, okay? So we just arbitrarily enter the parameters and DIgSILENT returned to us this result, right? Now, if you take this in terms of practicality, it might make a bit sense because at ultra high voltage systems like 132 kilovolt or 400 kilovolt systems, technicians are actually never working within the hazard zone. The large working distance we also have here of 15.7 meters actually ensure that even though the arc energy is very high, we can actually still operate at a safe distance to perform our work and never get closer to ground zero or zero distance where the arc flash is actually occurring, so we can safely stand here. And that will make the exposure to the arc flash negligible based on the distance. Now let's go ahead and look at the result on the load bus bar. Now here, the arc current or the short circuit current is at 30.6 kiloamps. The calculated incident energy is 150 joule per centimeter square, with the distance boundary or the arc flash boundary is about 6.6 meters. Now notice here the category levels have jumped from -1 here to category 4, which means serious stuff is going on in this bus bar here. By the way, if you found this tutorial useful and informative, I will appreciate a thumbs up. And if you'd like to see more power system content from CMTEQ channel, please make sure you hit the subscribe button. Great stuff. Thank you so very much for the support. Category 4 is serious level, okay? The PPE straight jump from -1 to 4. we only have 4 categories here, okay? Category 1, 2, 3, and 4. Now we're jumping straight to category 4 here, which require a full arc rated suit, as we can see here, a helmet, hood, and insulated gloves, so that you don't take chances, okay? Now, this is because the 150.1 joule per centimeter square here is already way above the entry level of 1.2 calories per centimeter square. If you calculate it, you're going to get about 37, so which straight you jump into category 4. So this places you right within a second degree burn based on that working distance of 6.6 meters. So that basically means anyone who attempt to come closer within this distance without proper protection, like a full rated suit here, he she going to be sustained burn injuries. Great. So the bottom line here is that if you know what your incident energy is, your dist bound or arc flash boundary, which define the distance at which the incident energy drops below 1.2 joule per centimeter square, which then is the entry level, then your PPE category is going to be either 1 or not applicable. So if you know what the parameters are, please make sure you dress accordingly with the required PPE category levels, okay? And for the 132 kilovolt substation here, the safe distance is 15.7 meters, which basically cover the entire area of substation. So do not get closer unless you are fully protected. And for the 33 kilovolts, so we got 6 meters, which is typically for indoor substations where you are not required to go closer unless if you've got PPE category 4 suit rated. Great stuff. So in terms of substation safety, electrical safety, those distances, the PPE distances, also guides power system engineers or substation technicians to properly label with proper warning signs as people approaches danger zone or area that's incident rated area in terms of your PPE categories. Great stuff. So this is why arc flash studies are not just for compliance exercises, okay? So they are critical in terms of design optimizations and safety plannings in electrical installations and substations setups, okay? So by analyzing these type of results, we can obviously define the PPE level as we've seen, adjust protections settings to limit exposure to incident energy, and also implement arc resistance design for substations safety. So that is it, guys, for this part 2 of this tutorial on arc flash analysis. A lot more can be said in this topic, but we're going to stop it at this point here. Thank you for watching. If you found it useful, as always, please give it a thumbs up and subscribe to CMTEQ channel. Drop your comment in the comment section if you have any suggestion or any insight in this topic. Until next time, stay tuned to CMTEQ channel. Cheers.